Hello guys, so this is going to be a small tutorial just to show you how can you create this kind of shells which are made of planar honeycomb panels. So the idea here is to show you how can you use Kangaroo Planarization Forces to do this. So I'm going to go a little bit fast on this one, assuming that you are already familiar with grasshoppers. So let's go ahead and get started. I'm going to hide these honeycomb panels that I have here. And I'm going to open my input surface, which is going to be the one that I have here. So the next thing I'm going to do is to open my grasshopper window. And I'm going to start by referencing my surface into my definition. So I'm going to go to my parameters tab. And then here on my geometry subcategory, I'm going to pick my surface parameter. So I'm going to right click here, set one surface, and select my base surface. And once that I have done this, I can simply go ahead and hide it from my viewport. Okay, so the next thing I'm going to do here is to extract my surface edges, as I'm going to use them for a later stage. So I'm going to go ahead and call a vrep component here, which is this one. And then I'm just going to simply plug it into my surface parameter. So now if I take a look at my outputs, I'm going to see that here on my edges output, I'm going to have 4 curves which represent the edges of my surface. Okay, so the next thing that we're going to do here is to extract the actual honeycomb pattern. And to do this, we're going to use a plugin called Launchbox. And for those of you who don't have it, I'm gonna make sure to add a link so you can download it and use it. So I'm gonna click here on my Launchbox tab, and in my panel subcategory, I'm going to pick the hexagon cells component. And this component is asking me for a surface to work, which of course is gonna be my input surface that I have here. And then I'm gonna go ahead and create a couple of sliders that go from 0 to 20. So something like that. And I'm gonna copy this one so I can control these two inputs independently. So I'm gonna plug one here and the other one on my V. And I'm going to play a little bit with these guys. Something like this, I think, should be okay. Okay, so the next thing we're gonna start doing is to start selecting the forces that we are actually gonna be using in our simulation. So I'm gonna go ahead to my Kangaroo tab, and then here under my forces category, I'm going to pick 3 of them. So the first one are gonna be some springs that we're gonna create. The second one is going to be, of course, the planarize force, which we're going to use to, as its name says, use to planarize our hexagons. And the third force is going to be a curveball force. And what this force is going to make is to constrain all the particles that I have on the edges of my surface to the boundary of it. So let's go ahead and start setting this one up. So I'm going to start with my springs, and the first problem that I'm going to encounter here is that if I call a curve parameter and plug it into my cells output, and I'm going to go and hide these guys over here. Okay, so if I go ahead and bake these geometries, what I'm going to see is that I have individual closed polygons, and in order to create some springs, what I need is to have individual line segments. So as you can see here, I have duplicate elements all over the place. So I can really easily fix this by exploding all these closed polylines. So I'm going to go ahead and call an explode curve component here, and I'm going to explode all these closed polylines. And the next thing I need to do is to have all these segments into one single list. So I'm going to call a panel just to see how is this information organized right now. And as you can see, I have all my segments in separate lists. So what I'm going to do here is to right click under my S output and select the flatten option. So I collapse all my lists into one single list. And once that I have done this, I can go ahead into my utility tab and look for a component which is called remove duplicate lines. So I'm going to pick that one. And I'm going to simply drag this line input to my exploded segments. And now I'm going to go ahead and hide these lines. And now if I pick this new component and bake it, I'm going to see that now I have individual line segments, which is exactly what I need to create my springs. So the next thing I'm going to do here is to connect these line segments to my connection input of my springs force. And as my rest length, I'm going to use the actual length of each segment. So the rest length value is, try to think of it as the length that my spring is going to try to reach at any point of my simulation. So as I want to keep the shape of my hexagons as similar as possible, I'm going to use the length of my segments as my rest length value. So I'm going to call a length component here. I'm gonna plug it into my segments, and then I'm going to plug that one into my rest length input. Okay, and I'm also gonna create a stiffness value, and for that I'm gonna create a slider, and I'm actually going to leave the value really low for this one, as I want my springs to be not so stiff in this case, because I need them to have certain freedom in order to achieve some planar hexagons. So I'm gonna move this slider down here, and I'm going to call it stiffness. Okay, so the next force I'm going to set up is the planarize force, which is this one. And what it is asking me to work is the vertices of the polygons that it's going to planarize. So we can really easily retrieve that by calling a control polygon component. So I'm gonna go ahead, select my control points component and plug it into my cells output that I have here. So now here I have a collection of my vertices, which I can specify here. And then I'm also gonna create another slider to set up the strength of this force. But in this case, I'm going to set up a really high value, as this is gonna be the main force that is going to drive my simulation. So I'm going to leave this value up to 800 or something like that. And I'm going to plug it here into my strength input. And then I'm going to call this slider planarize. Or something like that. Okay, so the last force that I want to set up is this one that it's called curve pull. And as I said before, what this component will do is to constrain all the particles or the vertices that I have here on my edges and prevent them from displacing outside this surface. So in order to do that, first I'm going to solve a problem similar to the one that we have here with our closed polylines, which is that we have a lot of duplicate points here. If I go ahead and bake this geometry, I'm going to see that I have a lot of repeated points in here. So I need to get rid of all my duplicate points that I have. So I'm going to solve this in a similar fashion. I'm going to go ahead and call a flatten component. And this time, instead of directly flattening this output, I'm using a component, as I want to maintain this path structure for this force. So that's why I'm calling here a flatten component. So then once that I have flattened all the points into one single list, I can go ahead into my utility tab and look for my remove duplicate points component, which is going to do the same as the remove duplicate lines. Just instead of removing lines, of course, it's going to remove any duplicate points. So now I can go ahead and bake this geometry just to check if I don't have any duplicate points. So as you can see, this is not the case. So the next thing I'm going to do here is to simply call a curve closest point component, so I can track down which one of all these points are actually located at the edges of my surface. So as I said before, I'm going to call a curve closest point component, which is this one that I have here. And this component is asking me for a set of points to evaluate. So of course, I'm going to use the points that I have created here. And it's asking me for some curves to project these points into. So in this case, I have all my edges here. And what I want to do is to separate each curve into a single list. So I'm going to call a graphed component here. So now I have these curves into individual lists. So I'm going to go ahead and plug this into my curve input that I have here. Okay, so now that I have all my points projected into my edges, I'm going to use this distance value to track down only the points that are actually on my edges. And the way I'm going to do is to find just the distant values that are in 0. So I'm going to call an equality component here to look for that condition. So I'm going to type here equality, this guy. And I'm going to plug this distance value into my first input. And here I'm going to right click and set the number 0. So now if I go ahead and take a look into this output, I'm going to see that now I have a Boolean list of a lot of values, and what I'm gonna do is to cool out all the elements that have the statement false. So to do that, I'm going to call a cool pattern component, which is this one that I have over here. And I'm going to select this list of points as that is the one I want to use to remove elements. And then for my pattern, I'm going to use this output that I have here. So now if I go ahead and hide everything that I have here, as you can see, now I have only the points that I need, which are the ones that are on the edges of my surface. And of course, I have the curves, which represent also those boundaries. So the next thing I'm going to do is to simply plug them into my component that I have here. So these are going to be the points that I'm going to be using, and these are going to be the curves. Okay. So now that we have set up correctly all our forces, sorry, here I'm missing to add a slider to set up the strength of this force. So I'm going to set this value, I think 500 or something like that. This is going to be a secondary force. I'm going to set that to, I don't know, something like 300 perhaps. And I'm going to call this curve pull. Okay, so now I have set up all my forces. So the next thing I want to do here is to start actually setting up the physics engine. So I'm going to call the Kangaroo physics component, which is this one. And I'm going to start plugging in all my force objects. So I'm going to connect my springs. Then I'm going to hold the shift key and connect my planarized force. And I'm going to do the same for my curve pull force that I have here. So for my anchor points, I'm not actually going to be using any for this simulation, as I already have this force which is constraining all the particles on the edges from moving beyond the curve. So I'm going to leave this with nothing, and I'm also going to leave the settings as they are. We're not going to mess with them right now. And for my geometry, I want to select the control points of my vertices, which are these guys. And as I'm going to get, as a result, the same vertices, I'm going to call a polyline component to start creating my panels after the simulation. So sorry, here I'm forgetting, I need to always flatten these force objects here. Okay, so now I have my polylines here, and then I'm going to call a planar surface component, and in this way we're going to be able to see at what point our hexagons reach that planarity stage. So for example, here we already have two flat panels here. So what else am I missing? I'm gonna add a timer so we can visualize our simulation, and I'm going to set an interval of 20 milliseconds so we can see our animation in a more dynamic way. So I'm gonna plug that here. And lastly, I'm going to add a Boolean toggle component so we can pause and restart our animation at any time. So I'm gonna pick it from here. So I think that would actually be it. I'm going to go ahead and try to hide all these components. So now I just simply need to set this toggle to false and my simulation is going to start. So as you can see, all my particles are displacing, trying to reach for that planarity stage. And what we can try to do here is to play, for example, with the stiffness of my springs, as I want them to have more freedom. So I'm going to reduce this almost to 0 so they can move more freely and reach that state more easily. So maybe I'm going to pause the simulation and I'm going to set this curve pull force a little bit lower and my planarize a little bit higher perhaps, and then I'm going to run again my simulation and see what happens. Okay, so now as you can see, all my panels are planar, so I can simply go ahead here into my planar surface component and bake these geometries into this new layer. And I think that will be it. So if I pause my simulation, we can see the original state of my surface, and then we can see the optimized surface with planar elements. Okay, so I think that will be all for this tutorial. I hope you find it helpful, and thanks a lot for watching.